All right, guys, we're going to talk today about those sampling methods that you covered in your random rectangles data collection. Okay, we were interested in that, how varied your different results were, and were they centered near where they were going to close to what the actual value was. Well, let's talk about each one of those methods and advantages and disadvantages to using those. All right. So the first one we're going to talk about is simple random sample. Simple random sample, let's kind of first write down here what our description of the method was. Okay. So it was definitely, it was the quickest way to do a simple random sample is to say that you're just going to put everything in a big bag, put everything in a big bag, shake it well. Okay. That indicates the randomization. Okay. Shake well and pull out the subjects and put them into wherever it is that you're placing them. Okay. Or survey them. Okay. Well, um, there's some key things here that we actually need to pay attention to. And as far as advanced placement goes, and probably even your TEKS, so the standards say there are some things that you need to know that this sampling method does. Okay, so first of all, it's important that you know this. Every um, subject, okay, that's in that big bag. So you put everything all in there, shake well. Every subject has an equal chance of being chosen. All right, so that's one key characteristic. Another one, and this one's a little harder to understand, but this is also equally important to understand. Every sample of a certain size. So, say I was going to take samples from Alito High School of samples of size 10. Okay? Every different every different representation has an equal chance of being chosen. And so let's talk about that. So that means that I could just as easily, if I did all 10th, 11th, and 12th grade in a bag, shake well, I could easily get all the last part of the alphabet of the seniors as opposed to the first 10 in the alphabet of the sophomores. Okay? Those have is equally likely to get those last 10 of the senior class as it is to get the first 10 of the sophomore class and to get the middle 10 of the junior class or the first 10 of the junior class or whatever mix up you have of those, they're all equally likely to happen. Okay, that's what happens when everybody's in a big bag. All right, talk advantages. Advantages, of course, one things that we're going to notice is that because you have randomness, reduces your bias. Okay, so that's one key thing. But the advantage also is that you have every sample is equally likely. Every type of sample is equally likely. Sometimes that's a disadvantage. If you want a representation of the senior class, I mean, of Alito High School, you could get all seniors, and is that actually going to give you the same, opinion as all Alito High School students? Okay, so sometimes you got to watch that. All right, disadvantages. So sometimes because you have so many, it could involve a lot of time, for large data sets. Okay, could take a lot of time to do that. Um, and what I just said a second ago, since all possible samples are equally likely, then you know some, it's possible that it's possible that some of these samples um, may not actually be representative, may not represent the population. If you're taking opinion of all Alito High School students and you happen to get all 10 seniors, well, they might not have the same feelings as all the students. Okay, so there's that one. Very good. So let's now talk about clustering. Okay, remember clustering a minute ago, or clustering on our random rectangles? That was whenever you had 5 different sets and hey, cluster, you're a group. I'm going to randomly select a group and then I will sample all of you. Hey, cluster. Okay, cluster and stratify are commonly mixed up, so I made a song about that I'll add on this page, the video of the song. Hey, cluster, you're a group. I will sample all of you. Hey, cluster. So here's the description of that. We're going to divide the subjects into clusters. So the key is that these clusters are supposed to be a little mini population. Okay. Um, our advisory classes that we have are not clusters. And the reason is because each one is not a mini representation of Aledo High School, because I have all sophomores. Okay. So even though I have all parts of the alphabet of the sophomores, that's not like all Aledo High School. Okay. So doing cluster sampling with with advisories wouldn't actually work here. Okay. So, hey, sample or divide into clusters, little mini populations, and then once you do that, sample all subjects in the cluster. All right. So there is the description of what's happening with that. Okay, advantage. It is pretty simple and quick and easy. Okay, so advantage, simple, quick, easy. So that's very nice on that. A disadvantage is that what happens if, the randomly chosen cluster may not be representative of the population. Okay, so let's think about that in our random rectangles. A minute ago, when we were talking about that, about the class's data, cluster 1, in fact, if I look back at my information, cluster 1 had 4.7. Can you see that? Cluster 1 was 4.7, and the other ones, the other ones were all around 7 or 8. So cluster 1 was not a representative cluster. Okay. All right. So that's the danger with that one. Okie dokie. Moving on. Stratified. So cluster is a grouping method. Stratifying is grouping. Those get confused. So the song goes, hey, cluster, you're a group. I will sample all of you. Hey, cluster. Okay, so that's what we got there. But then with stratified, if you remember correctly, we stratified by a trait. Okay, we made homogeneous groups. We said, ooh, I think I need to make sure I get all kinds of rectangles. So the description of this method, what we're going to do is we're going to divide the subjects into strata. Okay, that's kind of what, that's this particular group. Okay, and what that strata is it's homogeneous, yes, by a certain trait. Okay. So with our random rectangles, we we thought, maybe we ought to make sure we get all kinds of the rectangle sizes. So let's group them by size. So we had the small rectangles, the next biggest, the medium, the next biggest, and the largest. We had the different sizes. So I make sure that I get some of the small, some of the next one, some of the medium sized, some of the biggest. Okay, so we divide the subjects into strata by a certain trait. Then we randomly select one or more. I don't have to just pick one. So one or more subjects from each strata. I think I may have do that. I think on the random rectangles we just chose one item from each strata, but you could choose 3 from each strata, whatever. Okay. So in summary, our clustering was a type of group. Okay, the clusters were many populations, but the strata were homogeneous. Okay, advantage. Here's the advantage of that. It's pretty easy, so it's fairly easy to divide into strata. Okay, here's the best thing. It guarantees that every type, that was the key, that every type of subject is in the sample. That's the thing. At Aledo High School, if we want to make sure we get a good representative sample, we probably want to guarantee that we get some sophomores, some juniors, and some seniors. So we could stratify by grade level. Okay? So there's that. Now, the disadvantage is that, you may not know the important trait uh, to control, or how to stratify into the different groups, okay? So that there is no overlap in the strata, okay? For example, so the overlap, that could be a problem. Here's an example of a potential problem. If I wanted to, uh, if I want to get the opinions of the athletes and then the musicians, okay? So I don't just have a homogeneous, may not necessarily have a homogeneous group of the athletes at Aledo High School and the musicians at Aledo High School. And I get some of their, 20 of their opinions and 20 of their opinions. Because what happens? There could be some students who are athletes and musicians. They're in both programs. Okay. So see, there's an overlap that you might have to handle and figure out how to deal with. Okay. All right, very good. Now, let's go on to systematic sampling. So let's see what happened with our random rectangles with our systematic sampling. Okay, so the randomness comes in here so we randomly select the first item, okay? And this reminds me, we needed to make sure that there was randomness happening in all of these sections. Okay, so let's actually, I'll come back to that. We're going to look, we're going to identify where was the randomness in each one of these sampling methods. Okay, so here, the first item was randomly selected. Okay, then after we randomly selected, then choose every 10th item. I don't know what that is. Every 20th, every 5th, every 10th, whatever subject after that. Okay? So there you go. Very simple. Very simple to take that. So that's an advantage, of course. Okay? Very simple to take. Line them up. Take a random starting place, take every 50th one after that, okay? You can do that. You can do it, line them up alphabetically, start in a random place, take every 60th one after that, whatever. Okay, disadvantages. It's generally pretty good, but here's one strange thing, and I have this picture here to the side of this rainbow set to kind of demonstrate it in a concrete manner. So here's one possible disadvantage. There could be a hidden periodic trait, okay, in the data set. All right, and here's what I mean by that. Here's an example. All right, so let's pretend like this color wheel over here that I have, let's say that this is like a dartboard, okay? And I have my eyes closed and somebody says, "Hey, figure out what that what color is that dartboard?" Or no, I guess that's not really necessarily not a dartboard, but whatever. Okay, so I'm gonna randomly find a starting point. So I'm gonna randomly throw my dart, and I'm gonna go, okay, there it is. Okay, so I'm starting right there with the green. Okay, so now that I'm starting with the green, I want you to choose every fifth color after that. Okay, so watch how this goes. Here we go. There's my starting point. 1, 2, 3, 4, 5. I landed on green again. 1, 2, 3, 4, 5. I landed on green again. 1, 2, 3, 4, 5. I landed on green again. 1, 2, 3, 4, 5. Okay, so here's what just happened. Every single item in my sample was green. So if you say, okay, now open your eyes. What color were all of your samples? Or what color do you think that is over there? And I'm going to say, hey, it's got to be green. Every single thing that I threw at it, what landed on green. Okay. But that was because it was a periodic trait that was in there. Okay. So that could happen. It's kind of hard and abstract to think about what those are, but there's kind of a concrete method there. Okay, multi-stage, pretty simple on that one. Multi-stage just means that, let's see, let's do this purple here. So multi-stage just means that you're using more than one of the above methods. Okay. And so I won't go into that. But what about census? They're doing the 2020 census. Pretty much impossible to get everybody in that census. Very important. But that census, of course, is where the sample that they take is the entire population. Okay. An advantage, just FYI, because this is something that we would want to think about. An advantage of that could be that it's representative. Of course, it's representative. The sample is the population, okay? But a disadvantage could be, how much money are we putting into doing the 2020 census? Holy moly, tons of money. Very difficult and cumbersome. Very difficult and cumbersome. You know what else? Time consuming. They're taking the whole entire year to do this. Okay, time consuming, and for very large data sets. Now, if it's a small data set like the basketball team, no problem. Okay, I can handle that. All right. So there are your sampling methods. Let's talk about just one item in relationship to these. I want to make sure that we know, where does randomness come into play with every single one of these sampling methods, okay? Because randomization is how the sampling method attempts to reduce the bias, okay? So you're not having some kind of bias in there where you maybe even subconsciously are choosing something. All right. So let's take a look at our simple random sample. I can tell you right now that when we are shaking that bag up, that's making us have some randomness, okay? So that's where that goes there. So here, whenever we, on this clustering, we're dividing the subjects into clusters. Now it says sample all the subjects in a cluster. That was not a very good description. I probably should have put something else in there, like the fact that I should have said, randomly select one or more clusters. So maybe I pick, so sorry, my bad. Should have put that in there right there. Okay, so I randomly select one or more clusters, okay? And so that randomly selecting that cluster, that's where that randomization comes in. Stratified, where's that randomization? You are randomly selecting a subject from that strata, a subject from that strata, a subject from that strata. Okay, next, description of systematic randomization comes in when we randomly select the first one. Okay, all right, so all of those employ randomness, and that's an important thing to know. So I hope that helped you understand the sampling methods, summarize those sampling methods, and then, understand what the advantages and the disadvantages are of those various sampling methods.